Hello everyone, today we are going to implement this getting hit part of the mannequin from the turret. So when it shoots and when our health is fully depleted, the ragdoll is activated and character is killed. So that's what we are going to work on today. So everything will be done in C++. And we will use a Niagara particle component for the blood particle. So let's see how to do this today. Okay, so at the moment our turret can detect the player and it starts shooting. Actually for shooting, all it does is playing a sound effect and muzzle flash. That's all happens. So the next thing I want to do is implementing the damaging part for the player. So for that, actually there is an inbuilt function before actor take damage. This function actor take damage. What I'm going to do is I am going to override this function in our third person characters. This is the function, and I'm going to implement a health variable and implement damaging. So once the health is fully depleted, character should die. That means just mesh should go into the ragdoll mode and player should not be able to control the character anymore. So any movement input or this should stop working. Right, so let's do that part next. Before that, let me just decrease the thickness of this beam because of this thickness I don't see the muzzle flash properly. Why is it not changing? Right, changes are reflected here. Okay, now let me open the third person character and let's go to the header file. So here I want to override the take damage event. Can I just copy this? Actually, we should be able to copy this from the actor class also. Oh, we have to go way above for that. Okay, let me just paste it. Virtual float, take damage. This is the function. To make sure that we are properly overriding, I'll add the override keyword here. Shall we just move this above? That seems easier to read in this case. Okay, so this is the function. Take damage. We have to give damage amount, damage event, and a controller reference pointer. Oh, this part is too big. It doesn't have to be too big. Okay, now let's create this function. Right, here is the implementation. Shall we just copy this to the end? so I know where it is. And also, in order to implement damaging, I need a health variable, which I haven't set up yet. So under should health be public? I don't see a reason for that at the moment. So we can make it protected so the child classes can access it. So you property print read let's just use edit anywhere. Oh no, anywhere we shouldn't be able to edit. Let's say edit, no, edit anywhere should be fine. Okay, float health, float value should be 100. Right, so how do we implement this take damage? Since this function is a function that we override from a parent class, we need to call the parent function of the same function to make sure that if whatever is happening in the above function, we have to go do that too. So float damage cost, let's say, equals super take damage. We have to pass the same variables, damage amount and damage event. I'm just passing these variables, these parameters we get here. Event instigator and damage causer. Right, now the next thing I want to do is decrementing the health value with the damage caused. So also we need to make sure that our health value is not become any negative value as well. I mean, we don't really have any problem with that at the moment, but it's better to keep 0 as the lowest value to make it more consistent. So damage cost, let's set it to the min value, math min. If the current health value is less than the damage cost, then the maximum value damage cost should be is the current health value. So health and damage cost. Well, actually, since we haven't applied the damage yet, it kind of sounds wrong to use cost. So let's say damage to that's fine. Damage to cost also sounds bad, so damage cost, let's use it. And health minus equals damage cost, and we have written that. So damage cost. And one more thing, so if the character is dead, so let's do a check. If health is less than or equal to 0. Actually this just using equals to 0 will also work, but this feels much safer. Let's add a debug, sorry, UE log at this text. So when the character is dead, we will get that even though nothing happens. So we can see this part is being executed as we expected. Then after getting that part done correctly, we can look into how to enable the ragdoll and how to disable inputs. Oh, we haven't still called this function yet. That we have to do from the turret. CPP turret when we shoot. And here, even though we already have a reference to the character that the turret is trying to shoot, from this trace that comes under this trace beam part, in this line trace, I think I should do another line trace in the fire function also. So these are the things we need. Let me just copy that. We need the hit result, and we need the starting point, and we need the end point. And just like before, we need to ignore the cell factor, and we have the hit variable to see if we get a hit. So if the hit is true, that means we have hit something. We can check. No, we don't need to check. We can call this take damage function. Where is it? This take damage function on the actor that we hit. So this take damage is coming from actor class. So therefore we don't need to do any casting, or need to do any don't need to implement any interfaces, because with this hit result, dot get actor, we can access the actor that we hit. So from here we can call take damage. So damage amount, I'll just use 10, and F damage event. So we have create one. Let me do a simple Google search. F damage event. So under damage event we have point damage and radial damage, and this is a shooting. So point damage is the one more applicable. So let's go to that. And here for the constructor we need the in damage, that should be the damage amount, and a hit result, and shot direction, and damage type. I don't think we have to include this though. Let's see. So F point damage event, amount, let's use the same value 10, and the hit result, let's use this hit result, and short direction, direction is this beams forward. And this one could be a null. We don't have any damage types defined yet. Right, now here we can put, oh, this should be an damage event. What else? A controller event instigator. So this is a turret, it is an actor, and it is not controlled by any AI controller or the player. So maybe we can just pass null here, or we can use the default get instigator controller. Right, let's do that. And damage causer is this. Okay, right, now let's compile and see. Also, in order to see this character died text, we need to have the output log. And output log is already here. Now shall we use the classic layout? Oh, did it stop the compilation? Right, compilation complete. Let's play. Character died. Okay, so it is happening as expected. So, and the character should die only once, so we can prevent dying again and again if we simply add if health is less than or equal to 0, we can return 0. That would prevent character dying again and again. And we should enable ragdoll for the mesh, and also we should disable input. So to disable inputs, we can call disable input. Here we need to pass player controller, so we can get world get first player controller. This part should do. And we need to enable ragdoll on the mesh, so get mesh. This will return the mesh of the character. Set simulate physics. This should enable the ragdoll. Set this to true. But in order to ragdoll to work properly, we need to enable or set the world settings. Set the character mesh collision type to ragdoll. Here and collision type, I'll set it to ragdoll. Oh, we need to compile. Right, let's compile and see. Compilation complete. Let's play the game. See, now the character is dead. We can't move as well, and the turret is still shooting even after we are dead. So to prevent that, we can do something like this. We can get actually we have this is enemy, this one. This should return false if our health, if the character is dead. This should return false because a dead character is no longer an enemy. So we should return the result of health is larger than 0. Health larger than 0. Is this confusing? I hope not. So the result of this would be a boolean value, true or false. So if the health is larger than 0, this would be true. That means this would be a valid enemy. If the health is equal to 0 or less than 0, the result would be false, so this would not be an enemy. Also, the beam, laser beam, should not stop at the capsule because when the character is dead, because capsule is not something visible. So let's get capsule. Can we just call capsule? No. Component set collision. Set collision enabled. False. This itself may fix. Oh. The collision. Collision enabled. No collision. Right. So this part itself may solve the issue of not extending the laser beam when the character is dead, but having both ways would be better. Let's compile, right, and play. Right, now once the character is dead, turret resume sweeping around the perimeter. Okay, so the only thing remaining now is spawning the blood particle. So for that we can actually do it here. So if we get a hit, oh, we have the hit result. So damage. Right, in here, let's define a variable for the character, a public u property, bit defaults only. I want to spawn a Niagara particle for the blood, and I have already imported a blood particle somewhere. This one. So diff 20 diff. What's the variable type I need? So this is the function we have used, and as the reference we need 𝐿 system pointer. So we have to use this Niagara function library. Let me copy this, and here I don't get the autocomplete, so I should add that Niagara function library. Oh wait, I still don't get it. Okay, actually no, this is not what I should include. What I should include is this one. Niagara system should be implemented in Niagara system.h. Right, now you IntelliSense is working. I still don't get it. Right, this is cannot open source file. I think I have to enable that Niagara module here. So what's that? I think it's just Niagara module. Let's put that. Do I have to rebuild or something? So even though I get the error here, I just copy paste that Niagara system pblood and compiled. It is working, even though it shows an error here. So maybe we need to just close this and reopen. So there may be some loading issue of that Niagara module. Not really sure. Yeah, that seems to be the case. Okay, so now we have the Niagara module added to our character. Now let's see pblood. So we can assign pblood now here. Right, and all we have to do is call in this function. This function, so let's add this Niagara function library to our C++. Third-person character C++ file. Here, from this damage event, we can access the location of the hit. So Niagara, sorry, not F, Niagara Where is that? I don't get the suggestion, so let's copy. Oh wait, we have to have this Niagara component. This is really painful to copy paste things without getting suggestions, but I don't really have any alternative, so let me put this in my other screen. First parameter is world context object. We can see that here, but why don't I get the suggestion then? World context object is this, and Niagara system template is p.lut, and the location is fhit result. No, we can access it from damage event. Damage event. So actually the location cannot be accessed directly from the damage event. We have to convert this to first a point damage event in order to get the location. So what we can do is, if damage event damage type, we can check is of type point damage event, f point damage event. We have to see if this class ID, compare the class ID. If that is true, that means we have this damage event is a point damage event which is something relevant, something like a bullet hit, so we can access the location. So f location, so f vector hit location equals, not hot location, hit location. Now we need to cast this damage event to f point damage event type. For that we can do f point damage event pointer. We have to use the address of damage event, and from the casted type we can access location. Now we can access hit info, then location, like this. Similarly, let me do a copy. Let's have a rotator, and let's call this hit rotation. So from this we can access normal, and from the normal we can get rotation. Right, Now we can add location. Let's put this part also inside this, otherwise we won't have a valid location and no rotation. Hit location, hit rotation. Unfortunately I still don't get the suggestions. And the next thing is scale. If you don't remember, I am referring to this scale. F vector, let's use 1 1 1. That should be fine. And auto destroy, true, and auto activate, true, and ENC pull method. For that we need some header file. This one, Niagara Commons. ENC pull method. Let me copy that. I can't wait for IntelliSense to do its job. Auto release. Pre-card check. Not 100% sure what that means, but 𝐂𝐚𝐭𝐫𝐭 is you know about occlusion 𝐂𝐚 and other optimization methods, maybe something like that. So let's make that also true. Okay, right, now let's compile and hope we won't get any errors. Why can't they fix this in IntelliSense? Oh, is it compiled? Oh. Right, now we get the we got the blood, but why did it right, cool. So we get the blood particle as well. Awesome. So I'm gonna stop this episode right here, and thanks for watching. So as always, project files will be available here in the Patreon page for download, and if you would like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.